Hey, welcome. Whether you're at the self-checkout or you see an AI writing an email, there's this nagging question that always seems to pop up with new tech, and it's a really big one. This debate has been raging forever, right? Whenever some powerful new technology arrives, the first thing we notice are the jobs it makes obsolete. It's right there in our faces. But is that really the whole story? Let's dig in a little deeper. All right, so here's how we're going to tackle this. First, we'll talk about that big common fear. Then I'm going to show you a cool tool economists use to get the full picture. We'll put that tool to the test with an amazing case study, France's huge nuclear power program. We'll find a hidden job multiplier, see why the strategy behind the tech is so important, and then we'll wrap up by thinking about what this all means for us today.
So yeah, the story always feels the same, doesn't it? A new tech pops up and bam, the first thing we hear about are the jobs that are gone. You can just picture the headlines, right? Coal miners losing their jobs as a new energy source takes over. These are the direct hits, the ones we can see and feel. And yeah, they're often painful.
But here's the thing, this is so crucial. If we only focus on those visible job losses, we're missing almost everything. It's kind of like watching a magician make something disappear, but totally missing all the clever stuff happening behind the scenes that makes the trick work. We need a way to see the entire economic ripple effect, all of it.
Well, luckily for us, economists have a tool for exactly this. It's called the C/D method. Now, that stands for compensation and déversement, which is a French term that basically means spillover. And that's exactly what it does. It's designed to make all those invisible economic ripples, well, visible.
See, the C/C method makes us look way beyond just the factory gates. It's not just about, say, the welder who's replaced by a robot. It's also about the new jobs for the engineers who design that robot, the technicians who keep it running, and even the people working in the factories making the parts for it. It's about seeing all the downstream effects, the compensation for lost jobs, and the spillover of benefits into totally different parts of the economy. So let's break that down, right? On one hand, you have the direct effects, the stuff everyone sees, the coal miners who are out of a job, but also the construction workers who are building the new nuclear plants. But on the other hand, you've got the indirect effects, and these are so much harder to spot. We're talking about new jobs in supplier companies, jobs that pop up because cheaper energy lowers costs for every other business, and brand new roles that didn't even exist before. Okay, now for the perfect real-world test for this whole idea. We're going back to the 1970s. The world was in the middle of a huge oil crisis, and France made this incredibly bold choice. They decided to go all in on nuclear power. This was one of the fastest, biggest technological shifts any modern country has ever tried. And just look at how fast this happened. In just about 20 years, France totally remade its energy grid. They went from depending on fossil fuels to getting most of their electricity from nuclear. They built 58 reactors in that time. This was not a slow, gradual change. This was a revolution. So, the big question, what did this do to jobs? Well, at first glance, if you only looked at the direct, visible stuff, it seemed to confirm everyone's worst fears. The most obvious thing you saw was the French coal mining industry just shrinking. Yeah, the early research was pretty clear. To make 1 kilowatt-hour of electricity, nuclear power just needed less direct human labor than French coal did. The technology was, by its very nature, labor-saving. It looked like a textbook case of machines replacing people. Right, that's the obvious conclusion. If you stop the analysis right there, you'd have to say, yep, nuclear power killed French jobs. But what happens when we use that CD method? What happens when we start looking for those invisible spillover effects? Okay, get ready for this. The number they found was 1 to 5. Think about that. For every single direct job in the nuclear industry, an engineer, a technician at a plant, the economy was creating 4 to 5 more jobs somewhere else in France. That's not a small bump. That is a massive hidden job multiplier. So where on earth did all these jobs come from? Well, a few places. First, the supply chains for nuclear are incredibly complex, creating jobs in hundreds of other companies. Second, cheaper electricity was like a massive stimulus package for the whole economy. Just a 1 centime drop per kilowatt hour saved French industry 900 million francs. That's money they could use to hire and invest. Then you have the rise of new global giants like Framatome. And finally, you have this whole new world of high-skilled jobs in R&D, advanced manufacturing, and safety. But here's the kicker. This incredible outcome wasn't just because of the technology itself. Nope. It was about the strategy France used. That amazing job multiplier didn't just happen automatically. It was built piece by piece through smart national policy. And you can really see how much strategy mattered when you compare countries. So France started with American tech, but they made it their mission to master it and build their own industry from the ground up. They captured the whole value chain. Japan, on the other hand, relied more on foreign tech, and a lot of those economic benefits and jobs kind of leaked out of the country. And in the US and Canada, the plants actually had more direct jobs, but that ironically made them less competitive, which limited their total economic punch. But, even the most brilliant strategy can't stop the clock. Technology has a natural life cycle, and French nuclear power followed that classic S curve. There was this period of insane, explosive growth, and then it hit maturity. The plants were built, the country had the power it needed, and new orders just stopped. The whole industry had to figure out what was next. This quote from the head of the French power company at the time just nails the problem. The nuclear industry was this massive, centralized giant, but suddenly it was facing competition from smaller, nimbler things like natural gas turbines. It was a huge cultural shock, and it demanded a completely new way of thinking. So, what can we learn from all this? France's nuclear adventure leaves us with some really critical questions for our own future, as we face AI, green energy, and all kinds of automation. Can we expect the same kind of job multiplier from the tech we're developing today? How important is it to have a national strategy versus just letting the market do its thing? And here's a big one. How do we help people through those very real, very visible job losses when all the new jobs being created are invisible, indirect, and spread so thinly across the whole economy? In the end, I think the French nuclear story teaches us one huge lesson. What we see right in front of us is almost never the whole picture. The real, true impact of technology is usually hidden beneath the surface. It's in the ripples, not just the initial splash. And that leaves us with this final, crucial question. If we only ever focus on the jobs we can see disappearing, are we missing the chance to build a future with more jobs and better jobs than we can even imagine? Thanks for joining me.